Hi there, we're here today to talk about TIBCO accelerators. An accelerator is an intelligent, automated analytical system. It will ingest streams of data, it will detect subtle, hidden patterns inside that data, it will notify the business if thresholds are reached or if breaches are detected. It will then intelligently take automatic action. It will justify the action that it's taken, and it will continue to learn, so as new data comes in, or as the world around it changes, so its behaviour will evolve. This model lends itself to all industries, from high-tech manufacturing through telco to healthcare. To show you an example of that, though, here today, we're going to use the world of banking, credit card fraud detection. Along here at the bottom, we've got the existing landscape. So we'll have a quick look at how this problem is handled at the moment. So flowing through, we have our stream of data, and this data is going to be credit card payments. So all of our payment data comes through, and it arrives at the monitoring system. The monitoring system is able to categorize those transactions into two, more likely three different buckets. The first bucket with the green tick is valid transactions. These are legitimate and will be allowed straight through for processing. The red cross is detected fraud, and these will be stopped or will not be allowed through. The third category, though, is the question mark, and these are the transactions that the system is unable to determine what to do with. They look suspicious. We call them false positives, and these require further investigation. So these then will get passed along to our team of human investigators, and as we can see by their unhappy faces, they're going to be overwhelmed by that workload, and this is costing a lot of money, and this is taking a lot of time. That's the clock there. So this is a current process. How might a TIBCO accelerator improve this? Well, one way is to join together a whole lot of other information to give more context to that payment so we can make a smart decision. And there's some other ways that we'll look at as well. Starting with the data, though, the bank holds a wealth of information, including in that is CRM data. So this is all the information about the customer, their spending habits, the products that they own, their lifetime with the bank. We can join that onto transactional data. These are large volumes, ever-growing volumes of transactions that each customer is responsible for. Another category to join on is going to be fraud history. So this is using historical information to perhaps indicate what's likely to be fraud in the future. But there's other data that we can join onto that as well. One example is social data. What are our customers tweeting about? That might be a predictor of fraud. Other categories might be geodata or sensor data or demographic data. That's a lot of information. First thing we need to do is to join that all together. So in the new system we'll show in blue. The first thing we're going to do is use something called data virtualization, or DV, and that will allow us to integrate all of this information together. That then is going to get passed into the data science. And from here, we're going to segment the data, we're going to do some clustering, some analysis, and generate from that two models. The first of these is called a supervised model, and the second is an unsupervised model. A supervised model is based upon historical analysis. If this were fraudulent in the past, then based upon that, we can predict that this might be fraudulent in the future. The unsupervised model is based around anomaly detection. So based upon what appears to be normal, anything that is an outlier is by definition abnormal, and therefore warrants investigation. We would join these two models together, and then typically before adding it into the monitoring system, an officer from the bank may just need to go through a final approval stage. And then we'll push that down. So we're going to show this as augmenting the existing monitoring system. And there's some very good reasons why we would do that, why we would augment. This system has probably taken several years to implement. It's probably cost several millions of pounds or euros. The bank's invested a lot of time and money in that. So we will leave that in place and augment around it to make a smarter decision. So that model then gets deployed here. Now our stream of information comes through. Think of this as a finer grained filter sitting with the monitoring system. Now we're more accurately categorizing transactions as legitimate or as fraudulent. Not only are we calculating that more accurately, but we're also given a confidence interval, which I'll show as percentage. So we're even given a percentage rating of how confident the system is in the classification of that transaction. Coming out of this also is documentation. So the system's explaining in human readable form how it's arrived at that conclusion. Inevitably, there will still be some transactions that require further investigation. And these investigators are pulling together a lot of information to arrive at their conclusion. But we've done all this great work over here already to combine these data sources. So why don't we reuse all of that? And now our investigators have a single screen, making available to them all the information they need to finally conclude whether a transaction is fraudulent or legitimate. As we go through this, the system is firing out results, and the final step of an accelerator then is to take all of these results and feed it around. And that then comes in here as learnings. It's an intelligent system, it needs to learn. And then all of this data will be used to retrain the model, and an updated model then will get passed into the monitoring system. Therefore, the system continues to evolve, continues to learn, we continue to make smarter suggestions each time around. That example's from the world of banking. Equally though, this could be in healthcare, for example, a stream of patient data from instruments on the bed. We might make a decision based upon that and detect that there's a threatening condition, and the action might be to send an alert, get a crash cart to the patient's bedside, something like that. It could be that we have a machine in a factory, a stream of data coming through, a sensor readings from that machine, and we're monitoring to see if that machine is likely to break down, in which case we can either close it down, take it offline, or generate a works order for some maintenance. We can take this system further, this model, so we might choose to right place where we execute the model. You'll see it's a centralized enterprise deployment at the moment, but actually we can choose to execute this decision-making process offline, at the edge, in disconnected devices. And always we can choose to bring in even more data to further add to the wealth of information we're already using, so geodata or sensor data, for example. Thank you very much for watching. That is the TIBCO Accelerator.